I want to talk about another thing that we can do with our compound interest formula. So this A is the amount to which a certain P grows given a rate and a number of compounds per year, and then how many years we're doing this. One thing you can do when you're going to invest your money is you might sometimes want to know, how much do I want to have in some given future? You might know what you want to have. Okay, say you're saving for college, retirement, a car, whatever it is, you might know this. So what you might want to know is, how much do I have to invest? Okay, and so you can go to any bank and you can find your rate and your compounds right there, but this number, how much you invest, is totally up to you. So what we want to do is be able to solve for how much to invest in terms of all this other stuff. So if I wanted to write P equals by itself, essentially what I'm going to do is divide by this rest of the equation. So divide by the 1 plus r over n to the nt, and we're going to divide that on both sides here. Okay, and so how much you need to invest is going to equal the amount you want to have divided by 1 plus r over n to the nt. Okay, so a simple algebraic process gives us this. Now what we call this formula is the present value formula. You can see it in your notes there. So the P is what you need to invest. Okay, and that's going to be a dollar amount. The A is to have this amount in the future. And this is why sometimes you're going to see the P written as present value, PV, and then A is sometimes written as FV, or a future value. R is still your percentage rate. Okay, N is still the number of compounds in a year, and then T is still your time. So we can answer this question now. How many dollars should parents invest at the birth of their child in order to provide their child with $50,000 at age 18? So assume the money earns an interest of 8% compounded quarterly. So anytime you're asked how much should you invest, that's going to be your P, your present value. Now the A is how much you want to have. So they want to give their child $50,000 at age 18. Man, I wish my parents had thought of this. So $50,000 divided by, and then 1 plus, well, your rate of 8%, so that's going to be 0.08, divided by n, which in this case it's compounded quarterly, so n is 4. And then this is going to be to the 4 times, well, let's see, at age 18. So that's 18 years after the birth of the child, so 4 times 18. Okay, so to be able to type this into our calculator, we're going to actually go 50,000 and then divided by, and then I want you to open up 2 sets of parentheses. Okay, one of them is right here, and it's going to be for the entire denominator. We're going to keep that together. I'm going to show you this here in red. Okay, and then we have the 1 plus 0.08 divided by 4, close that parentheses, raise it to the power of 4 times 18, and then we'll just close that parentheses off just like so. Okay, so we have 50,000 divided by, and I'm going to do two sets of parentheses. Now 1 plus 0.08 divided by 4, close that parentheses, and then raise that to the power of 4 times 18, and then we'll go ahead and hit enter. Okay, we can see that it did this all right here. And here is your amount, and we'll round that to the nearest penny. So the P, or the amount that you have to invest, will be $12,015.94. Okay, so this can be very useful in projecting for your goals. So if you want to have a certain amount in the future, you can say, well, how much do I need to invest today to attain that goal later? So if these parents invested $12,015.94 when their child was born, they would be able to give their child a check for $50,000 when they turned 18. All right, so that is the present value formula.